Here are the answers for the day 4 warm-up. Write the electron configuration for each. Question A, we have a potassium atom. To write the electron configuration, we need to know how many electrons there are so that we can then fit them into the appropriate sublevels. Capital K is atomic number 19 on the periodic table, so it has 19 electrons. Let's follow the off-bound diagram to fill those electrons into the correct locations. The first sublevel that gets filled is 1s, and it can hold 2 electrons. Then 2s is used. That can hold 2 electrons. Then 2p is used. It can hold 6 electrons. Then 3s, that can hold 2. Next comes 3p, which can hold 6. And next comes 4s. Let's put 1 electron into that level. I have located 19 electrons. 2 and 2 is 4, and 6 is 10, and 2 makes 12, plus 6 makes 18, plus 1 makes 19. Question B, let's do the electron configuration of the phosphide ion. And the symbol is a capital P with a -3 charge in the corner. Again, we want to know how many electrons that has. Capital P is for the element phosphorus, which is atomic number 15 on the periodic table. But this is a phosphide ion with a -3 charge. It has a -3 charge because the phosphorus atom has gained 3 additional electrons. The ion has a total of 18 electrons. Follow the off-by diagram starting with sublevel 1s and moving up until 18 electrons have been located. 1s2, 2s2, 2p6, 3s2, and 3p6. If you add together the numbers in the upper corners, it adds up to 18. Question C, the lead-2 ion that has the symbol Pb with a +2. Lead is atomic number 82, so a regular lead atom has 82 electrons. But this is a lead ion with a +2 charge. It has a +2 charge because it has lost 2 valence electrons. The lead ion has 80 electrons. Now that is a lot of electrons to locate and write out the full electron configuration. So you're given the hint. Consider using noble gas form for a shorter answer. To write noble gas form for the lead ion, you write down the symbol for the noble gas, which is at the end of the previous period of the periodic table. Pb is in period 6. So I'm going to find the noble gas that's at the end of period 5. That is xenon. The electron configuration for the lead ion begins in exactly the same way as xenon's entire electron configuration. But lead has additional electrons that xenon does not have. Those additional electrons fill into the 6s sublevel. 2 electrons fit in that sublevel. Next comes 4f, holding 14 electrons, and then 5d, which has 10 electrons. Here are the 80 electrons. Writing the noble gas xenon at the beginning of the configuration accounts for the first 54 electrons. Then there are 2 more, that's 56. Then 14 more, that's 70. And then 10 more, 80 electrons.